One typical property of particles is inertia. Speed lower than c means that a certain amount of energy is confined by a force against free propagation. Such energy will now exist recursively in form of particle. As far as we know, this force is continuous and constant since mass is conserved in ground state. Electron and light are two very different energy systems. Even if the particles show gradients of dualism, the speed lower than c is conserved together with many other features in a way that is just impossible for free propagating waves. The force of confinement defines how much energy is slower than c and the following inertia. Beyond particle, a more massive system, as example the Earth, will thus have a lot of energy not free propagating. The confined energy that possesses inertia can be thought as the result of a force causing two free propagating waves a sort of deceleration from c. This is the meaning for slower than light, with F being the cause and E the effect. The formula is nothing else than E equals mc squared. Both values refer to the same effect, while the energy in this equation is energy in form of free propagating waves. Therefore, if you take the recursive energy and virtually remove the confining force, you get how much free propagating energy is contained in the particle. This energy is the wave equivalent, the theoretical yield if you transform the whole inertia, which is not so easy since fundamental particles are always stable with a minimum amount of energy. The system in ground state cannot become free propagating unless it interacts with its antiparticle, the same exact system but opposite charge. This way the whole system can annihilate into free propagating wave, hence the c squared, converting 100% of the inertial energy. It must be pinpointed that this equation is quantitative, but the same amount of inertia can be conserved in many ways when we make qualitative evaluations and consider energy density, and we need both for a clearer description of the system. EMC is an equivalence between energy in form of waves and particles, but this doesn't mean they are the same under every other aspect and so freely exchangeable. We saw the features of particles compared with free propagating waves, and inertia is one of them. A moving system is considerable with more inertia and energy along some direction. This additional energy comes from the relativity, and velocity is conserved as momentum through inertia. And for now m0 and I mean the same. To consider this new amount of energy, we add a gamma factor to mc squared. This is the Lorentz correction to deal with relativity of interactions. Ignoring fields to make it easier, the increase of inertia and energy from velocity doesn't exist until interaction. It is true because of this relativity, but it will be real only when interaction will occur. It follows that this extra energy is not into the particles, so neither can be part of the decay process with spontaneous emission. This velocity comes from this specific relativity, and by equivalence it's the same from this frame of reference, with the additional energy shifting to the other particle. The conservation of momentum and energy makes sense only looking at the relativity as a whole, because they belong to no one. Here the fairest evaluation would be the rate of approach, and we see how both systems have inertia without velocity as total energy. This is true until the instant before the interaction. Only now with the collision, velocity becomes the kinetic force we were predicting, and total energy and inertia actually consider the relativity. After the interaction, the systems move apart again, having just the inertial energy. Combining mass and velocity, we make a big slow system and a smaller fast one. having the same kinetic force. Even though the overall energy matches, results of interaction will be very different, and this is one of the reasons beside quantity we need quality. Here we have an example of how a very fast object can concentrate a huge amount of energy in a small size. With charges too, mass and velocity variation will affect inertia and the result of interactions. An increase of the overall energy won't change the amount of interaction as with collision. Obviously, the interaction is continuous and radial, but the trajectory changes because of the relative inertia and the conservation of momentum. Anyway, knowing the energy, we can use electromagnetic field interaction to define charge and mass. Pictured is the first positron ever observed. Inertia emerges in waves interacting with particles too. Energy of the radiation is transferred to a system moving slower than c. The interaction shows recoil, but waves have no real mass, so it's not a momentum transfer. The effect is completely on particle side and doesn't exist within waves. Recoil appears because particles have inertia and there is transformation between free propagating and standing energy.